How to use a rotary evaporator. Objectives: to familiarize yourself with the use of a rotary evaporator instrument, also known as a Rotavap. A rotary evaporator is used to remove solvents at a lower temperature than they would normally boil at atmospheric pressure. This can be achieved by reducing the pressure of the system using vacuum. The solvent in the round bottom flask will evaporate. The vapors will rise, condense in the condenser, and drip down in the receiving flask. A round bottom flask should be no more than half filled with your solution. Use a cork ring to hold your round bottom flask. If it's too big, try flipping it over to accommodate the flask. Before using the Rotavap, ensure the trap is empty, the bump trap is clean, and that the water bath has sufficient water in it. It is recommended that the water bath be filled with distilled or deionized water to avoid scale buildup and having to clean the bowl often. For low boiling point solvents that you would like to evaporate, such as diethyl ether or dichloromethane, the water bath can be kept at room temperature. Otherwise, for higher boiling point solvents, turn the water bath on. The water bath does not need to be very hot, since the boiling point of your solvent is lower due to the vacuum. In most cases, 40 degrees Celsius is sufficient. The trap for dichloromethane and ether can be created by connecting a vacuum flask between the condenser and vacuum line and sticking the vacuum flask into a bucket of ice and water. The flask is usually connected to the evaporator's bump trap, but we don't use them at our institution. Connect the flask to the adapter using a plastic clip called a keck clip. Turn on the water for the condenser. Make sure the tubing is securely draining into the sink. Turn on the vacuum source. A hissing sound should be heard from air being pulled through the stopcock. Close the stopcock on the evaporator by turning it perpendicular to the bleed valve. The hissing sound should stop, and the pressure inside the apparatus will decrease further. The partial vacuum will help hold the flask securely onto the bump trap. To make it easier, we added a small tubing on which you can simply put your thumb to control the pressure. Begin rotating the flask at a medium rate by adjusting the rotation or knob to roughly 110 RPMs or to 1/3 of the maximum rotation value. Lower the flask into the water so the flask is partially submerged. Be sure the flask is not positioned so low that the joint with the plastic clip is in the water. Allow the solution to evaporate. Solvent should collect in the large round bottom flask reservoir. There's no set amount of time required for complete evaporation. If the expected compound is a solid, keep evaporating until a solid or thin film appears. A film may form if the temperature of the bath is above the melting point of the solid, if crystallization is slow, or if the warmth of the bath prevents crystallization. If the expected compound is a liquid, evaporate until the approximate expected volume is seen and it appears that the liquid level is no longer changing. Evaporation can also be tested by lifting the flask out of the water bath, drying the outside with paper towels, and feeling the flask with your hands as it rotates. If solvent continues to evaporate, then the flask will feel cool to the touch. When it appears that the sample has completely evaporated, allow it to remain in the reduced pressure system an extra minute to remove any final solvent residue. To stop the evaporation, reverse all the previous steps. Lift the flask from the water bath, stop the rotation, open the stopcock, and turn off the vacuum source. Always keep one hand on the bottom of the round bottom flask. To remove the flask, you may need to twist it gently to unlock it. Turn the evaporator, water tap, and the water bath off. Empty out the trap by disposing the solvents in the appropriate waste containers and clean out the bump trap. The residue in the round bottom flask should contain the desired compound, but may still contain trace amounts of solvent. Once it's fully dry, the mass can be obtained and the compound analyzed. Clean the glassware and put away the equipment.